Okay, let's start. Number 10. Sundaland. A skull came up through a dredging pipe, mixed into sand meant for a construction site. It was human, and it was old enough that the species it belonged to had supposedly vanished from the region tens of thousands of years before. The seafloor it came from was marked on every map as ocean. The map was wrong. 20,000 years ago, the islands of Sumatra, Java, and Borneo were not islands. They were highlands on a single continuous landmass, stretching from the Malay Peninsula to the edge of the Java Sea, a region geologists call Sundaland. Rivers larger than anything flowing through the region today cut across its lowlands toward a coastline far beyond where any shore exists now. Homo erectus had been living across this landscape for over 1 million years, moving along its floodplains, hunting elephants, rhinoceroses, and water buffalo that no longer exist anywhere in the wild. It was one of the largest unbroken tropical lowlands on the planet, and almost none of it survived the next 20,000 years. At the height of the last glaciation, global sea level sat roughly 120 meters lower than it does today, deep enough that coral reefs now hundreds of kilometers from the nearest coastline once sat on dry, exposed seafloor. As the ice sheets covering North America and Scandinavia collapsed, the water came back in pulses rather than a steady creep. One surge, known to geologists as Meltwater Pulse 1A, raised global sea level by roughly 18 meters in only 4 to 5 centuries. On a shelf as flat as Sundaland, a rise like that does not push the coastline gradually inland. It erases entire provinces in the time it takes a forest to mature. By the time sea level leveled off near its present position around 6,000 years ago, more than half of Sundaland was gone, broken into the islands that appear on maps today. In 2025, Leiden University archaeologist Harold Berghaus and his colleagues, publishing in the journal Quaternary Environments in Humans, described the first vertebrate fossil assemblage ever recovered directly from this drowned landscape. More than 6,000 specimens across 36 species, dredged from a buried channel of the Solo River beneath the Madura Strait, near Surabaya. Among the bones were 2 skull fragments belonging to Homo erectus, dated to roughly 140,000 years old. Komodo dragons, river sharks, elephants, and water buffalo turned up in the same haul, a single frozen cross-section of an entire ecosystem that had no coastline and no name on any chart for thousands of years. Cut marks on several of the animal bones show deliberate, skilled butchery, including the selective hunting of strong, healthy adult cattle, a hunting pattern not previously documented in earlier Homo erectus fossils from the island of Java, where the population had long been assumed to be isolated and unsophisticated. The Madura Strait material suggests something different: contact, learned behavior, possibly even exchange between hominin groups moving across a landscape that no longer exists in any form a person could walk across today. Whatever language, technology, or social structure these early humans built across the lowlands of Sundaland disappeared with the land itself. There is no equivalent of a buried village waiting to be excavated, because the entire stage those people lived on is now sediment, sand, and shifting sandbanks beneath the Java Sea. Sundaland is the second largest drowned continental shelf on Earth, smaller only than the one off northern Australia. Indonesia exists today as an archipelago of more than 17,000 islands for one specific reason: a single continuous landmass broke apart underwater, not because any of those landmasses were ever truly separate to begin with. Every strait between Sumatra, Java, and Borneo is the visible remainder of a country-sized region that used to be dry ground. Sundaland was not the only Ice Age landmass the warming seas swallowed whole. To the south, an entire continent lost nearly a third of itself the same way, and what it lost has only recently started giving its secrets back. Number 9. Sea Country. Divers found stone tools sitting on the seafloor exactly where someone had set them down. Nobody had buried them. Nobody had moved them in roughly 8,500 years. The ocean had simply arrived around them and left everything else untouched. At the end of the last ice age, the coastline of Australia sat as much as 160 kilometers farther out to sea than it does now. Aboriginal peoples had already been living on the continent for at least 65,000 years,
occupying coastal plains, river valleys, and fresh water springs that have not stood above water for thousands of years. Archaeologists and Aboriginal communities call this drowned territory sea country, ancestral land that traditional owners maintain cultural and spiritual ties to, even though it now sits permanently beneath the waves. In 2020, maritime archaeologist Jonathan Benjamin of Flinders University and a team of colleagues published the results of the Deep History of Sea Country project in the journal PLOS1, announcing Australia's first confirmed underwater Aboriginal archaeological sites. Benjamin chose the search area deliberately. The coastline directly above these underwater sites, the Burrup Peninsula and the islands of the Dampier Archipelago, together known as Murujuga, already held one of the densest collections of rock art on the planet. More than 1 million petroglyphs carved into the rock, some dated to 40,000 years old or more, depicting now extinct animals such as the thylacine and the giant flat-tailed kangaroo. Murujuga was inscribed on the UNESCO World Heritage List in July 2025 for exactly this reason. Between 2017 and 2019, Benjamin's team combined aerial laser scanning, sonar mapping, and direct diver surveys along this same coastline. They located 2 underwater sites. At Cape Brugier, divers recovered more than 260 stone artifacts scattered across the seafloor in water as shallow as 2.4 meters. At Flying Foam Passage, a single stone tool sat beside a fresh water spring 14 meters down, exactly the kind of location a Pleistocene community would have chosen to camp beside on dry land. Dating placed some of the Cape Brugier material at roughly 8,500 years old. Benjamin estimated that more than 30% of the Australian continent, an area of roughly 2 million square kilometers, larger than Greenland, was submerged by post-glacial sea level rise, and almost none of it had ever been surveyed for archaeology, because almost nobody had thought to look beneath the surface. The artifacts at Cape Brugier had not been swept far from where they were originally used. Their layout on the seafloor still resembled an intact living site rather than debris scattered by current and storm. That detail changes what the rising sea actually did to this record. It did not necessarily destroy tens of thousands of years of Aboriginal occupation on the continental shelf. In many places, it appears to have simply buried it, the way a flood buries the contents of a house rather than demolishing them outright. Australia's coastline, as drawn on every modern map, shows only the dry remainder of the continent. A third of the territory where Aboriginal Australians lived, hunted, and held ceremony for tens of thousands of years was quietly removed from the historical record because the ocean reached it first. Sea country is not a figure of speech for the communities who use the term. It describes with geographic precision 2 million square kilometers of ancestral ground that is still down there, waiting. On the opposite side of the world, a single drowned village would prove something just as important about what the sea preserves, that the right conditions underwater do not only protect scattered stone tools, they can preserve an entire settlement, walls, wells, and the people who lived inside it included. Number 8. Atlit Yam. A stone circle still stands exactly where it was built roughly 9,000 years ago, arranged around a freshwater spring that no longer exists in any usable form. It sits 12 meters underwater. Nobody relocated it, the sea simply rose around it and never left. Around 9,000 years ago, on what is now the Mediterranean coast of Israel, a Neolithic community built a settlement on a low coastal peninsula near the mouth of the Oran River, close enough to natural springs to dig stone-lined wells by hand. The people of this village, now called Atlit Yam, combined farming, herding, and fishing in the same economy, among the earliest known communities anywhere to rely on all three at once. They built rectangular stone houses. They buried their dead inside the settlement, close to where the living slept. They carved fishhooks and needles from bone, ground wild grain, and stored caraway seeds and wild grapes for later use. None of them had any way of knowing that the coastline beneath their feet would not exist for their grandchildren. Marine archaeologist Ehud Galili discovered the site in 1984 while surveying the seafloor near Atlit for shipwrecks, and decades of underwater excavation since have revealed houses, wells, and a semicircle of 7 megaliths, some weighing as much as 600 kilograms, arranged around a freshwater spring and carved with cup-shaped markings consistent with a water ritual. More than 60 human burials have been recovered in situ, the only site in the Mediterranean where that is true underwater. Radiocarbon dating places the settlement between roughly 9,000 and 8,000 years old. As post-glacial sea levels climbed, the Mediterranean coastline pushed steadily inland, and by around 7,000 years before the present, Atlit Yam was fully submerged, its wells filling with salt water far beneath the surface. A separate research team, led by volcanologist Maria Pareschi of the Italian National Institute of Geophysics and Volcanology, has proposed a faster, more violent ending, a flank collapse of Mount Etna roughly 8,500 years ago, capable of sending a 40-meter tsunami across the eastern Mediterranean within hours. Piles of fish bones found stored as though ready for trade support the idea of a sudden abandonment, though the megaliths, still standing after 9 millennia, argue against a wave strong enough to have flattened the village outright. The skeletons buried at Atlit Yam carry their own evidence. Several show bone damage in the ears consistent with repeated cold water diving, a sign that diving for shellfish was a routine part of daily life. A woman and infant buried together carry the earliest confirmed case of tuberculosis found anywhere in the human archaeological record. Whatever ended the village, slow inundation or sudden wave, the people of Atlit Yam left behind the clearest surviving picture in the Mediterranean of what early farming, coastal life actually looked like day to day, preserved by the same rising water that erased the ground beneath it. Every coastal Neolithic settlement on Earth carries the same vulnerability that submerged Atlit Yam. It was built at the edge of a sea whose level has shifted by more than 100 meters over the last 20,000 years. The modern Israeli coastline now sits roughly a kilometer inland of where this village once stood, which means an entire category of early human settlement, the first farming communities built directly on Mediterranean shorelines, is largely missing from the archaeological record everywhere, except the handful of places where the seafloor happened to preserve it instead of scattering it. While farmers along the Levant watched their coastline retreat meter by meter, a much larger world a few hundred kilometers to the east had already disappeared in one motion, and its loss may be the oldest flood story humans still tell.
Number 7. The Persian Gulf Oasis. For perhaps 100,000 years, one of the most habitable landscapes in Southwest Asia sat exactly where the Persian Gulf is today. Then the Indian Ocean took it back almost all at once, and the people who had lived there longer than recorded history began walking inland to start over somewhere else. Before the Persian Gulf existed in its current form, the basin underneath it was dry land for most of the last several 100,000 years, fed by the Tigris, the Euphrates, the Karun, and the Wadi Batin rivers, along with springs rising from aquifers beneath the Arabian Peninsula. Picture a green, river-threaded lowland ringed on every side by some of the most punishing desert on the planet. The desert surrounding this basin grew nearly uninhabitable during repeated periods of extreme aridity when temperatures climbed and surface water vanished across most of the peninsula. The Gulf Basin itself, lower, wetter, and shielded from the worst of that drying, would have stood out as a refuge in a region where almost nothing else offered reliable fresh water. In 2010, archaeologist Jeffrey Rose of the University of Birmingham published a paper in the journal Current Anthropology proposing that this basin functioned as a long-term refuge for human populations, a hypothesis now known as the Persian Gulf Oasis. Rose's proposal based partly on his own fieldwork. For the preceding 6 years, he and his collaborators had documented over 60 new archaeological sites along the modern Gulf shoreline, several containing tools older than 75,000 years.
Rose's review of historical sea level data showed the basin standing above water from roughly 125,000 years ago onward, reaching its largest exposed extent precisely during the driest periods in the surrounding hinterlands, watered by rivers running through what is now empty desert and seafloor alike. Genetic and archaeological evidence from across the Arabian Peninsula, Rose argued, points to human populations repeatedly contracting into refuges like this one, potentially surviving in the region tens of thousands of years earlier than standard out-of-Africa migration models had assumed. Then, beginning around 8,000 years ago, rising water from the Indian Ocean breached the basin and flooded it permanently, submerging what may have been one of the longest continuously inhabitable landscapes in the ancient Near East. Archaeologists working the modern shores of the Gulf have documented a wave of fully developed settlements appearing abruptly around 7,500 years ago, complete with architecture, ceramics, and established trade networks, with no visible earlier village stage in the local record. Rose's hypothesis offers a direct explanation. Those settlements were not new societies starting from nothing. They were the displaced population of the Gulf Oasis, arriving along the surviving coastline because the center of their world was already underwater. If Rose's hypothesis holds, some of the earliest complex village societies recorded in the ancient Near East were refugees before they were settlers, pushed out of a landscape that had supported their ancestors for over 100,000 years. By Rose's own account, the most decisive evidence for the hypothesis lies on the floor of the modern Persian Gulf itself, a body of water that may cover one of the longest continuously inhabited landscapes in human prehistory, and remains almost entirely unexplored by archaeologists to this day. Thousands of kilometers to the north, an entirely different kind of land bridge was vanishing under a colder, slower flood, one that quietly decided which animals and which humans would reach an entire hemisphere first.
Number 6. Beringia. A corridor of land wide enough to swallow 1,000 kilometers once connected two continents, and for most of the time it existed, almost nobody on either side knew the other one was there. Then the corridor went under, and the two halves of the world it had joined never touched again on foot. During the last ice age, so much of the planet's water was locked into continental ice sheets that global sea level dropped by as much as 122 meters below where it stands today. Where the shallow Bering Strait now separates Russia and Alaska, that drop exposed a stretch of land nearly as wide as Texas, connecting Siberia to North America. Geologists call this exposed region Beringia. It was not simply a corridor passed through quickly. Mammoths, horses, bison, and other Ice Age megafauna lived directly on Beringia itself for thousands of years, grazing across a landscape that functioned as its own ecosystem rather than a bridge between two others. So did the first humans to enter the Americas. Reconstructing exactly when Beringia stood open has proven difficult. A 2023 study in the journal PNAS, led by geophysicist Tamara Pico of the University of California, Santa Cruz, used local sea level modeling at the Bering Strait to argue that the land bridge may have remained flooded later into the glacial period than previously believed, possibly not fully exposed until sometime after 35,700 years ago. The bridge's final disappearance, when rising seas closed the strait for good, came more recently still, somewhere between roughly 13,000 and 11,000 years ago, as the great ice sheets of North America and Eurasia collapsed. The land in between did not vanish in an instant. Sediment cores pulled from beneath the modern Bering Sea by the United States Geological Survey, part of ongoing work with the University of Alaska Fairbanks, led by geologist Beth Casey, show layers of ancient freshwater lake sediment buried beneath marine mud, evidence of standing lakes on Beringia dating from roughly 45,000 to 9,000 years ago before the ocean finally closed over them. Separate research led by paleogeologist Sarah Fowle of the University of Alaska Fairbanks, using sediment cores and sonar surveys of the strait's modern seafloor, suggests Beringia was wetter and more fragmented by marshland than the dry, grassy tundra long pictured in textbooks. That detail may resolve an old puzzle.
Mammoths crossed into North America in large numbers, while woolly rhinoceroses, built for drier terrain, largely did not. The land bridge was never a uniform highway open equally to everything that approached it. It filtered species before it disappeared, and made the filtering permanent. Genetic evidence adds a human dimension to the same picture. In 2014, geoscientist John Hofecker of the University of Colorado Boulder, writing in the journal Science with colleagues Scott Elias and Dennis O'Rourke, argued for what geneticists call the Beringian Standhill hypothesis. The ancestors of all Native Americans likely paused on Beringia itself for several thousand years, isolated from both Asia and the rest of North America by ice on either side, before finally moving south once a corridor opened. Every human population currently living in the Americas, from the first hunter-gatherers to descend onto the continent to the more than 1 billion people living there today, traces back to groups that crossed a corridor of land no longer above water. The Bering Strait, only 82 kilometers at its narrowest point today, is the flooded remainder of the route that populated 2 continents. It is also one of the least explored stretches of seafloor on the planet. Cold water, strong currents, and meters of accumulated sediment make direct excavation almost impossible, which means the physical record of the single most consequential human migration in history is still sitting, unexcavated, beneath the Arctic Ocean. Beringia was not the only land bridge an ice age built and a warming planet erased. On the opposite side of the world, a smaller, shallower one disappeared in a way that was far more violent. Number 5. Doggerland. Fishing boats and sand dredging vessels working the North Sea have hauled up mammoth tusks, lion bones, and a fragment of Neanderthal skull, all from water where nobody should be finding land animals at all. They came up from a country that used to be there. At the height of the last ice age, Britain was not an island. A landmass now called Doggerland connected it to mainland Europe across what is today the southern North Sea, a region of rivers, marshes, lakes, and woodland that supported human occupation for tens of thousands of years before it supported Mesolithic hunter-gatherer communities specifically. In 2001, a shell extraction company working the Zealand ridges off the Dutch coast dredged up a fragment of frontal bone along with Middle Paleolithic hand axes and flint tools. In 2009, paleoanthropologist Jean-Jacques Hublin of the Max Planck Institute for Evolutionary Anthropology in Leipzig and his colleagues, publishing in the Journal of Human Evolution, identified the bone as Neanderthal, likely a young adult male roughly 60,000 to 70,000 years old, the first Pleistocene human fossil ever recovered from the floor of the North Sea. Archaeologist Vince Gaffney of the University of Bradford has spent more than 15 years mapping the same lost territory through the Europe's Lost Frontiers project, reusing seismic survey data originally collected by oil and gas companies to reconstruct Doggerland's rivers, lakes, and coastlines in extraordinary detail. By around 10,000 years ago, rising post-glacial seas had already begun shrinking Doggerland from a single continuous landmass into a contracting cluster of islands. The end came in 2 distinct stages. Gradual sea level rise had already submerged most of Doggerland by roughly 9,000 years ago, leaving behind what Gaffney's team calls the Dogger Archipelago. Then, around 8,150 years ago, an underwater sublandslide off the coast of Norway, known as the Storegga Slide, displaced thousands of cubic kilometers of seabed sediment and triggered a tsunami across the entire North Sea, with wave run-up reaching as high as 20 meters in the Shetland Islands and 10 to 12 meters along the Norwegian coast. In 2020, Gaffney and colleagues publishing in the journal Antiquity identified the first confirmed physical trace of that tsunami preserved inside a submerged river valley off the Norfolk coast, a distinct, violently deposited sediment layer sitting exactly where their models had predicted it would be. Their work suggests the surviving Dogger Archipelago took the brunt of the impact and that scattered islands may have persisted for a few more centuries after the wave struck before vanishing entirely beneath the North Sea. Whatever population still lived on the archipelago when the wave struck had no warning system and nowhere higher to climb. Later modeling work puts the number of people directly affected somewhere between 700 and 3,000, a small figure for modern standards, but for Mesolithic Europe, a meaningful fraction of the communities living along that coastline. What the tsunami did not finish, the rising sea did. Within a few more centuries, the last fragments of Doggerland disappeared beneath the water for good. The seabed keeps surfacing its own evidence. Trawl nets working the Dogger Bank, the shallowest remnant of the old landmass, regularly bring up the bones of mammoths, lions, and reindeer, animals that once stood on dry ground where cargo ships now pass overhead. An entire Mesolithic homeland, complete with its own rivers, forests, and burial grounds, lies beneath one of the busiest shipping lanes on the planet, mapped in more topographic detail today than some countries that still stand above water. Doggerland drowned slowly, then violently, across nearly 2,000 years. Farther east, an entire sea filled almost overnight, and some of the people who fled it may have carried the memory of that single flood into the oldest stories still told today.
Number 4. The Black Sea Deluge. A freshwater lake sitting more than 100 meters below the level of the modern sea turned to salt water within a single human lifetime. The flood that may have done it sits at the root of one of the oldest stories most people on Earth have heard at least once. Before roughly 7,600 years ago, what is now the Black Sea was a smaller, shallower body of fresh water, cut off from the Mediterranean by a natural sill beneath the Bosporus Strait. Around its shrunken shoreline, Neolithic farming communities took advantage of fertile exposed land during a period of regional aridity that geologist William Ryan has described as drawing people inward toward whatever reliable water remained. The lake supported its own distinct community of freshwater mollusks and fish, entirely separate from anything living in the saltwater Mediterranean nearby. In 1997, geologists William Ryan and Walter Pittman of Columbia University's Lamont Doherty Earth Observatory published sediment core evidence showing an abrupt transition from freshwater to saltwater mollusk species at a depth corresponding to roughly 7,600 years ago. Their interpretation, as global sea levels rose after the Ice Age, Mediterranean water eventually climbed high enough to breach the Bosporus sill, pouring into the Black Sea basin with what Ryan and Pittman calculated as the force of roughly 200 Niagara Falls. Water levels in the basin may have risen by as much as 15 centimeters a day, climbing more than 100 meters in total before the system stabilized, drowning thousands of square kilometers of formerly dry shoreline within months rather than centuries. The hypothesis remains genuinely debated. Other geologists, citing differences in shoreline dating and stratigraphy, argue for a slower, less catastrophic refilling spread across a much longer period. What is not in dispute is the underwater evidence that followed. In 2000, oceanographer Robert Ballard, the same researcher who located the wreck of the Titanic, led an expedition off Sinop, Turkey, in partnership with archaeologist Frederick Hebert of the University of Pennsylvania and the National Geographic Society. Side-scan sonar identified an ancient shoreline roughly 100 meters down, complete with freshwater snail shells, a drowned river valley, and what appeared to be a collapsed wooden structure with worked timbers. A robotic submersible recovered a piece of that wood and dated it to roughly 7,000 years old. Ballard himself was careful afterward to call the find suggestive rather than conclusive, since drifting debris had mixed in with the site and complicated the dating. But the shoreline itself, sitting tens of meters below where any Neolithic community would have built if the water had always stood this high, matched Ryan and Pittman's flood model directly. If the catastrophic version of the flood is correct, communities living around the freshwater lake would have watched their farmland disappear within a single generation, fast enough to push displaced populations outward into the river valleys of Anatolia and the Balkans. Ryan and Pittman went further, proposing that the scale and suddenness of the flood could have seeded the deluge narratives that appear independently across several ancient Near Eastern traditions, including the Mesopotamian Epic of Gilgamesh and the biblical story of Noah. Whether or not the Black Sea flood is the literal origin of those stories, the geology underneath the connection holds up on its own.
A lake that took thousands of years to stabilize disappeared under salt water in a window that could be measured in months. The Bosporus and Dardanelles Straits today sit at depths of only 110 and 103 meters, shallow enough that the same glacial-era sea level swing that drowned this basin once kept it completely sealed off from the world's oceans in the first place. The Black Sea flood reshaped a single basin within the span of human memory. Tens of millions of years earlier, on the far side of the same Mediterranean region, sea level did something far stranger to an entire stretch of Europe. It broke the continent apart into islands and kept the dinosaurs living on at least one of them unusually small.
Number 3. Hatzeg Island. For tens of millions of years, there was no such thing as a single landmass called Europe. There was a scattering of islands, and at least one of them was home to dinosaurs roughly the size of large dogs, descended from animals that elsewhere on the planet grew large enough to fill a building. During the late Cretaceous, roughly 100 to 66 million years ago, global sea level stood far above where it sits today. Geophysicist R. Dietmar Mueller of the University of Sydney, modeling ancient ocean basin volumes, has estimated Cretaceous sea levels at roughly 170 meters higher than the present, and some independent reconstructions place the peak even higher. At that elevation, much of what is now Europe sat below the waterline, covered by shallow seas where calcium carbonate from microscopic algae built up into the same soft white chalk that still forms the cliffs of southern England and northern France. What remained above water was not a continent, it was an archipelago, a chain of islands of wildly different sizes scattered across a warm, shallow sea. One of those islands, now called Hatzeg Island after the Romanian basin where its fossils are found, covered an estimated 80,000 square kilometers, smaller than the modern country of Austria. Hungarian paleontologist Franz Nopska first proposed in 1914 that the unusually small dinosaur fossils he was studying from the region represented a genuine island fauna, not juveniles of larger species that simply hadn't finished growing. For nearly a century, the idea remained an unconfirmed hypothesis. In 2010, paleontologists Michael Benton of the University of Bristol and Zoltan Siski of the University of Bucharest, publishing in the journal Paleogeography, Paleoclimatology, Paleoecology, confirmed it using bone histology. Thin sections cut from the limb bones of the Titanosaur Majorosaurus docus showed the same fully mature, fully remodeled internal structure found in old, full-grown sauropods many times its size, proof that these were not young animals waiting to grow larger. They were adults that had simply stopped growing small. Majorosaurus weighed an estimated 900 kilograms to 1 metric ton. Its closest titanosaur relatives elsewhere on Earth, animals like the South American giant Patagotitan, reached an estimated 69 metric tons. Majorosaurus was not alone on Hatzeg Island, and not every animal there got smaller. The hadrosaur Telmatosaurus and at least 2 species of the small ornithopod Zalmosis shared the same landscape, both reduced relative to their mainland relatives, consistent with what biologists call the island rule. Limited food and limited territory on small islands tend to shrink large animals across generations, while enlarging small ones. Overhead, the opposite happened. Hatzegopteryx, an Asdarchid pterosaur with an estimated wingspan of 10 to 12 meters and a skull more than 2 meters long, patrolled the same island as the dwarf titanosaurs below it. With no large theropod dinosaurs present to compete with on Hatzeg Island, paleontologists studying its unusually thick, muscled neck and reinforced skull have proposed that Hatzegopteryx filled that vacant role itself, hunting dwarf sauropods and iguanodontians as a flying animal large enough to take down prey many times its own size.
The dinosaurs of Hatzeg Island were not failures or evolutionary dead ends. They were a textbook case of island evolution operating exactly as ecological theory predicts, in both directions, preserved in stone for 66 million years, until a Hungarian baron pulled their bones out of a Transylvanian riverbank and refused to accept that they were simply juveniles. The same sea level rise that carved Cretaceous Europe into an archipelago also set the upper size limit for everything stranded on Hatzeg Island. Most reconstructions of the dinosaur age picture a planet ruled by enormous animals roaming continuous continents. Europe during this period offers a different picture entirely. A world of drowned lowlands and isolated islands, where the available land could fit a herd of titanosaurs the size of large dogs, but nothing larger. 60 million years after Hatzeg's islands finally rejoined a draining, reshaping Europe, an entire sea would disappear on the far side of the same basin, then return in one of the fastest, most violent floods the planet has ever recorded.
Number 2. The Zanclean Flood. The entire Mediterranean Sea dried up. It stayed empty for longer than the entire existence of the genus human. Then it refilled so fast that the water level rose more than 10 meters in a single day at its peak. Around 5.6 million years ago, tectonic movement near what is now the Strait of Gibraltar closed off the connection between the Mediterranean basin and the Atlantic Ocean. Cut off from its main water source and sitting in a hot, evaporative climate, the Mediterranean began drying out. Rivers that had once emptied into open sea instead carved canyons up to 2,500 meters deep into the exposed seafloor as they chased the retreating water downward. Canyons comparable in scale to the Grand Canyon, cut not over millions of years, but within the few 100,000 years the basin stayed dry. This period, known as the Messinian salinity crisis, left behind rock salt deposits across the dried basin, more than a kilometer thick in places, the largest evaporite deposit on the planet. The desiccation lasted roughly 270,000 years. Then, 5.33 million years ago, the Atlantic found a way back in. Geologist Daniel Garcia Castellanos of the Institute of Earth Sciences Jaume Almera in Barcelona, publishing in Nature in 2009, used borehole and seismic data to reconstruct what happened next. Water carved a channel through the Gibraltar region, and once it broke through, the flow accelerated catastrophically. Garcia Castellanos and his team calculated that roughly 90% of the entire refilling occurred in under 2 years, with peak flow rates reaching an estimated 100 million cubic meters per second. For comparison, the Amazon River, the largest river on Earth, drains an average of about 209,000 cubic meters of water per second. The Zanclean flood moved water at more than 3 orders of magnitude beyond that. At its most extreme, sea level inside the Mediterranean basin climbed by more than 10 meters in a single day. A 2024 study in the journal Communications, Earth and Environment, examining sediment evidence from southeastern Sicily, identified a second flood pathway through a marine corridor that carried water onward into the eastern Mediterranean, suggesting the basin filled in at least 2 distinct, violent pulses, rather than one continuous surge. Whatever life had managed to survive the Messinian desiccation, isolated in pockets of residual salt lakes and brackish lagoons scattered across the dry basin floor, was overwhelmed within months by an inflow larger than any river on the planet today. The flood repopulated the Mediterranean almost from nothing, carrying Atlantic fish, mollusks, and other marine life back into a basin that had spent hundreds of thousands of years as an empty, salt-crusted desert, sitting more than 3 kilometers below global sea level at its lowest points. The Zanclean flood is the largest known flood in this planet's geological record, by a wide margin. A sea roughly the size of the modern Mediterranean, more than 2.5 million square kilometers, went from a near-total desert basin to a fully connected ocean in less time than it takes a child to finish elementary school.
The canyons the Messinian rivers carved into the dry seafloor still exist, buried beneath more than a kilometer of marine sediment under the floor of the modern Mediterranean, a fossil landscape of dry riverbeds sitting directly beneath some of the busiest shipping lanes on Earth. The salt desiccation left behind never went anywhere either. Sicily and several other Mediterranean regions still mine rock salt and potash today, directly out of the kilometer-thick Messinian layer, pulling a usable resource out of the same evaporite crust that once was the floor of an empty sea. If an entire sea can disappear and return within the span of 2 human generations, the obvious question becomes what it means when an entire continent disappears and simply never comes back.
Number 1. Zealandia. There is an 8th continent on this planet, nearly the size of half of Australia, and 94% of it sits underwater right now. It was not formally recognized as a continent until 2017. Most people alive today have never heard its name. Around 105 million years ago, the eastern edge of the supercontinent Gondwana, which at the time included Australia, Antarctica, South America, India, and a region that would eventually be named Zealandia, began to stretch and pull apart. By roughly 80 million years ago, the rifting was complete, and Zealandia had separated fully from the rest of Gondwana, drifting away as its own block of continental crust in the southwest Pacific. At that point, much of its surface still stood above water, forested, mountainous, and biologically distinct, carrying its own lineages of plants and animals away from the rest of Gondwana on a slowly sinking raft of crust. American geophysicist Bruce Lewandowski first proposed the name Zealandia for this continental fragment in 1995, but it took more than 2 decades of additional seafloor mapping, rock sampling, and gravity surveys to build the formal case. In 2017, geologist Nick Mortimer of GNS Science in New Zealand and 10 co-authors published their findings in the journal GSA Today, demonstrating that the region satisfied every established geological criterion for a continent: elevated bathymetry compared to the surrounding ocean floor, a distinct and varied collection of granite, schist, and sedimentary rock, crust between 10 and 30 kilometers, thick against roughly 7 kilometers for typical oceanic crust, and continuous boundaries enclosing an area of 4.9 million square kilometers, well beyond the threshold for a mere microcontinent. As Gondwana finished breaking apart, the crust beneath Zealandia stretched and thinned dramatically through the late Cretaceous, and thinner crust sits lower against the mantle below it. By approximately 23 million years ago, according to later reconstructions, nearly the entire landmass had subsided beneath the waves. Today, only its highest points remain visible, the islands of New Zealand and New Caledonia, representing roughly 6% of the continent's total area. Every plant and animal lineage that evolved on Zealandia before it sank faced one of 2 outcomes: extinction or survival on whichever island stayed above the rising water. In 2017, the same year Mortimer's team published its formal case, the International Ocean Discovery Program's Expedition 37-1 drilled 6 sites into the Zealandia seafloor and recovered cores containing pollen from southern beech trees and spores from ferns, dated to be between roughly 50 and 80 million years old. Those plants had grown on dry land, in a temperate forest, at a location now buried under more than a kilometer of Pacific seawater. New Zealand's distinctive native wildlife, its flightless birds, its ancient reptile lineages, its plants with no close living relatives anywhere else, are understood by biologists as descendants of species that rode an entire sinking continent down to a handful of surviving peaks. The vast majority of Zealandia's biological and geological history now exists only as a record buried under a kilometer or more of Pacific seawater, accessible through deep-sea drilling rather than ordinary excavation. Geography textbooks teach 7 continents, because 7 is how many stand far enough above sea level to draw cleanly on a map. Zealandia did not stop being a continent the moment it sank.
The granite, the crustal thickness, and the defined geological boundaries that make something a continent were present the entire time, simply hidden beneath several kilometers of South Pacific Ocean. It took until 2017 for geologists to formally agree that a landmass does not need to be visible to be real. An area larger than India had been sitting there, fully continental and almost entirely unseen for the whole of recorded human history. 10 worlds. The fastest disappeared in under 2 years, when the Mediterranean refilled fast enough to drown a new stretch of shoreline every single day. The slowest took 23 million years to go under, and it is still down there. What connects every entry on this list is timing. Sea level looks fixed only because human history happens to have unfolded during one of the rare stable stretches in its long record of change. The next coastline on any map is simply where the water happens to be standing right now. If you want to see what else the ocean has been hiding, click the video on screen.